Hi everyone. I want to go over a question when you have a positive charge inside both the magnetic field and the electric field, but it goes on a straight line without being bent by the magnetic field. So let's look at this question. A positively charged particle moves through a uniform electric and magnetic fields. Electric field is going out of the page. It is represented by a dot. The magnetic field is pointing to the left. What would be the direction of the velocity of the charge? You guys know that if you have a positive charge would receive a force, electric force from an electric field in the same direction as the field lines. That is always the case. Yeah. So again, a positive charge would receive an electric force from the electric field in the same direction as the electric field lines. And you see the positive charge and you see that the electric field lines are pointing out of the page. Therefore, the electric force has to point out of the page. So I can say Fe is basically pointing out of the page. If Fe is pointing out of the page and the net force on this charge is supposed to be 0, that means that Fb has to go into the page. So Fb is going into the page. Going into the page is shown by a cross. Now, I want you to use the right-hand rule when you would have your thumb in the direction of the velocity. Your forefingers should show the direction of the magnetic field, and coming out of the palm will show the direction of the force. So if you do that, if you point your forefingers in the direction of the magnetic field, such that coming out of your palm will go into the page, and that would be the direction of the force, you see that your thumb should point down. Yeah, and that should be the direction of the velocity of the charge. Yeah, so the answer would be 4, which is basically D. Yeah? So remember that the force of the electric field and the force of the magnetic field, they have to cancel out such that the net force is 0. If you do not want the charge to be deflected by the magnetic field, there should be an electric field in here to apply a force in the opposite direction of the magnetic force.